we'll be going through these various topics, a quick introduction to our team. We're all part of the data and tech consulting company called Cervelo. So our area of focus is STEM education. And so in particular, we decided to look into like how societal factors can affect like women's choice to pursue STEM career as well as education. So this analysis would be impactful for any governmental or nonprofit agencies working to close the STEM gap for women in US. So the approach we took was that we used census industry and education data to get at the education and industry information, while we use the WPS index data, which is an index formulated by Georgetown University to get into the different societal factors. At a high level, we see that women are represented less in both education and industry, that is STEM. And if looking more closely, we see that like the representation is even lower in STEM fields like computer, maths, engineering, and architecture. So I'll hand it over to Kalai.
Thank you, Sonakshi. As part of the analysis, we have done the top 10 states in STEM education and the industry. So it's clear that the national trend of the women being employed in STEM is less than majoring in the STEM fields. So we see that some states have high representation of women in STEM industry. So the key insights from here is the women has the highest STEM education percentage in Massachusetts, which is like 15%, and the highest women employment in STEM industry is around 29%. So in states with large cities, migration could affect the disproportionate representation of women in STEM education and as well as in the STEM industry. Next slide, please. Coming to the top 10 STEM majors and industries, women have strong STEM education areas are in nursing, psychology, which translates into the medical industry where women are employed highest. So the key insights here are top 10 education majors account for 53% of the total women population, and the top STEM industry for women are medical, finance, education, and so on. So medical stays top with 70%. Next slide, please. So here we will look at this women's STEM education impact on STEM industry. So the top states with high percent of STEM major and industry are clustered at the Northeast. And most of the South states have the lowest percent of women in STEM major and lowest percent of women in STEM industry as well. Over to Kathy.
Thank you, Kalai. So the next part of our analysis, we cross-compared the WPS index that Sonakshi referenced in the beginning of our presentation to our percent of women majoring in STEM and percent of women currently working in STEM industries. This view right now is looking at the WPS index compared to women who majored in STEM fields. We found that there is actually a positive correlation here. So where there are more women majoring in STEM fields, they have a higher index score. And similar to what Kalai had just mentioned on the previous slide, the Northeast is still clustered at the top right, and the South, more conservative states are clustered in the bottom left, meaning lower percent of women majoring in STEM-related fields and lower index scores here. Next slide. This slide, we are looking at the WPS index score compared to percent of women working in STEM or in STEM industries. We found, again, a positive correlation, and we've found the same trend as the Northeast in the top right, southern states in the more bottom left corner. But one other trend that we saw here that we found interesting was the Midwest was actually all clustered together right below the northern states. So not the highest percent of women in STEM industries and not the highest index score, but just right below the Northeast cluster. So I'm going to hand it back to Sonakshi.
Thank you, Katie. So this correlation matrix kind of summarizes the different trends that we saw. So we do see that the percent women with STEM major and who are in STEM industry, they're positively correlated with all the different sub-indices, as well as the WPS index itself. And this goes to show that like societal factors can significantly impact women's education and career choices. And I'll hand it back to Katie for recommendation and next
Yep.
steps.
So in conclusion, based on all our analysis, by cross-comparing the WPS index and the census data, we are able to prove that there are societal influences at play that have an impact on women's decision to enter a STEM-related career or education. To help resolve this, we want to encourage states and federal governments to actually start looking into their laws to help level the playing field for women, whether that is having mandatory equal pay, access to different healthcare laws, and overall safety for women, as shown in the WPS index score. To further develop our analysis in the future, we would love to look at to account for migration more thoroughly and to actually start to look at this over time to see if there are any historical impacts that happened that cause any shifts.
Thank you.
And thank you.
Thank you.
Our team will be presenting on the global gender pay gap. The team members include Emily, Sarah, Vanessa, Mona, and myself, Juanita. Problem statement: which of the indicators from the UN Human Development Report have the strongest correlation with gender pay gap? Women perform 66% of the world's work, produce 50% of the food, but earn 10% of income and own 1% of the property. This is why we are presenting this topic. Our presentation will follow the following format: background, resources and data sets, methodology and analysis, results, conclusions, and insights. We will start with data sets. As a team, we compiled several data sets, but we decided to focus on the UN Human Development Report data and Allostat gender wage gap by occupation. We chose UN data for various measurements, and ILO data includes our target variable. We merged the data by year, but missing several countries, narrowed down the components, identified target outcome gender pay gap. Measured components include labor force participation, share of seats in parliament, education measurements, gross national income per capita, maternal monthly rate, adolescent birth rate, life expectancy. Now Vanessa will introduce the methodology and analysis section.
Thank you, Juanita. So we kicked off the process with one of the most important steps of data analysis, which is to clean the data and make sure that all the missing values are taken care of before we merge and transform data sets into one big data frame for further analysis. We then explored the data, conducted a principal component analysis to reduce dimensionality and to extract top features that explain the most variance in the data. Since the data contains both numerical and categorical variables, before we split the dataset into 80% training and 20% testing, we prepared the dataset by one-hot encoding the categorical variables. To achieve the highest accuracy, we experimented with different models, which we then used to predict gender pay gap, as well as identifying the components that have the greatest impact. We started with a multiple linear regression, and this is the benchmark for performance. We then moved to the random forest algorithm, which builds a strong predictive model as an ensemble of many weak predictors. And most of the times, it actually outperforms other models. We also used a supervised multi-layer perception neural network to look into nonlinear complex relationships in the data. I will now pass the time to Emily to talk about the results of these models.
So in reviewing the various performance and error metrics, Random Forest far exceeded performance compared to the other models that we evaluated. The R-squared was much higher, showing that it had much higher explanatory value, and the error metrics of MSE, RMSE, and MAE, in all cases, Random Forest had the lowest average error. On the next slide, we'll talk about the various components that we looked at. So we looked at, from a random forest model, we looked at the permutation importance, but we also took into consideration from the linear model and the PCA analysis, which components showed strong significance. And so in the end, we narrowed in on life expectancy, maternal mortality rate, the percentage of men that had begun secondary education, and the percentage of the national parliament that had female representation. And now Sarah will cover our visualization, insights, and conclusions.
Thank you, Emily. So just wanted to quickly show we made a Tableau dashboard visualizing the global gender pay gap. Now, this is available on Tableau Public, so you can dig into the data a little bit more. It highlights the country's individual pay gap by year, as well as the different components for countries that we used for our model. So going back, there are conclusions and insights. To reiterate, the random forest model was the best model for predicting the wage gap. We also identified 4 components that had the greatest impact on the wage gap. And from this, our recommendation is to focus efforts and resources on healthcare, education, and leadership to address these components. Our team also looked at our learning from this process, and the biggest takeaway was the importance of the data process in the start of the project, and then also the teamwork, so collaboration and being able to learn from one another. With that, thank you for your attention and the opportunity.